Video is on approximating non-perfect square roots and other irrational numbers. So just as a review, we know that perfect squares are numbers whose square roots are whole numbers. For example, we know that the square root of 64 is 8, 8 times 8. We know that the square root of 100 is 10, 10 times 10. And we know that the square root of 9 is 3, 3 times 3. However, when we get into non-perfect squares, there are numbers whose square roots are not whole numbers. Some examples of non-perfect squares are any not on our list of 15. So the square root of 56, we can't multiply a number times itself to get 56. The square root of 17 is not on our list. We can do the square root of 16, we can't do the square root of 17. The square root of 31 is not on our list. We can do the square root of 36, but not the square root of 31. Any number that is not on our list of 15 that you cannot multiply a number times itself is going to be a non-perfect square. Because we have non-perfect squares, it means that our answers are going to be decimals. So we're going to have to estimate. That's what the word approximate means. When we are approximating non-perfect squares, we are estimating. We're going to round and find the easiest answer, the decimal answer. So for number 1, we are going to estimate the value of the square root of 50. Now, the square root of 50 is not on our list. However, we could break it down and say that the square root of 50 is between the square root of 49 and the square root of 64. 50 is in between those two numbers. We know that the square root of 49 is 7, 7 times 7. We know that the square root of 64 is 8, 8 times 8. And so we know that the square root of 50 is going to be somewhere in the middle of 7 and 8. So it's going to be between 7 and 8. We don't know the decimal yet, but we know it's going to be in between those two whole numbers. So we want to figure out which one is it closest to. So if I start at 49 and go to 50, we only have to go up 1. So it's only 1 away from 49. In order to go from 64 to 50, we have to go 14. So therefore, we know that 50 is closer to 49. The square root of 50 will be closer to the 7 than the 8. It should be just a little over 7. And then we want to come up with a decimal. Because it is so close, we can do a little bit of guess and check work. And we want to pick a decimal that's a small decimal, a decimal close to 7. So 7.1. If we were to multiply 7.1 times 7.1, we could write that out. 1 times 1 is 1. 1 times 7 is 7. We're done with the 1, so I put my placeholder of 0. 7 times 1 is 7. 7 times 7 is 49. We add it up. 1 plus 0 is 1. 7 plus 7 is 14. 1 plus 9 is 0. 4 plus 1 is 5. And we have 2 decimal points. 50.41 would be 7.1 times 7.1. So a good estimate is 7.1 because 50.41 is close to our square root of 50. We're trying to get those numbers to be as close as possible. That decimal is very, very close. We both get 50 as our whole number, and so 7.1 is our good estimate. For this problem, we have the square root of 22. We cannot solve the square root of 22, so we're going to break it down and pick the two that are closest. The square root of 16 is just under 22. The square root of 25 is just over 22. The square root of 16 is 4, 4 times 4. The square root of 25 is 5, 5 times 5. So we know that our number is going to be between 4 and 5. Now, let's decide which one it's closer to. In order to go from 16 to 22, we have to go up 6. We go up 6. 16 to 22 is up 6. In order to go from 22 to 25, we go up 3. So therefore, it's going to be closer to the 5 than it is the 4. We want to pick a decimal point that's closer to 5. So we could pick a decimal point and guess and check our work. We can guess about 4.7. The 0.7 is closer to 5 than, let's say, 4.1. And so if we multiply it out, 4.7 times 4.7, just to check our work, 7 times 7 is 49. 7 times 4 is 28. 28 plus 4 is going to give us 32. We're done with the 7, so I bring down my 0. 4 times 7 is 28. 4 times 4 is 16, plus 2 is 18. Add them up. We have a 9. 2 plus 8 is 10. 8 plus 3 is going to give us 11, plus another one is going to give us 12, and we end up with 22.09. Again, 22.09 is very close to our original number 22, and so 4.7 is a good estimate. For number 3, we're going to estimate the value of the square root of 103. First, we need to figure out what whole numbers we're looking at. So a smaller square root would be the square root of 100, which we know is going to be 10 times 10. The larger square root would be 121, which is going to be 11 times 11. Now, we want to see which one it's going to be closer to, because we know it's going to be between 10 and 11, but to find the decimal, we want to know which one it's closest to. 100 plus 3 gives us 103, so we only have to go up 3. To get from 103 to 121, we end up having to go up 18. And so we know that it's going to be closer to the 100, closer to the 10. So if we want to do a little bit of guess and check work with our answer, we could guess an answer such as 10.2. That 0.2 decimal is a smaller decimal, closer to the 10 than, let's say, 10.8, which would be closer to 11. So again, I'm just going to double check my answer, guess and check work. 2 times 2 is 4, 2 times 0 is 0, 2 times 1 is 2. We're done with the 2, so I put down my placeholder of 0. 0 times 2 is 0, 0 times 1 is 0, 0 times 0 is 0. I put down on 2 more placeholders because we're done with both of those values. 1 times 2 is 2, 1 times 0 is 0, 1 times 1 is 1. Add up the values and we get 4, 0, 4, 0, and 1. And we end up with about 104. It is slightly higher than what is our actual answer, but it is still relatively close. Again, when we're approximating, we are estimating, we're trying to get a close answer. And so we can say that 10.2 is a close estimate. Number 4, which of the following square roots is best represented by point A? So let's look at each answer choice. Our first answer choice is the square root of 7. We can't solve the square root of 7, so we break it apart. We can break it down into a smaller number, 4. The square root of 4 is 2, 2 times 2. And our larger number is going to be 9, the square root of 9 being 3, 3 times 3. 7 is in the middle of those two square roots. If this number would fall between 2 and 3, but point A is between 3 and 4, we know that 7 is not a correct answer. Looking at B, the square root of 12, we can break that apart. A smaller square root would be the square root of 9, which is 3 times 3. A larger square root would be the square root of 16, which is 4, 4 times 4. 12 is a possible answer choice, but we're going to keep solving to see if there is a better one. Letter C gives us the square root of 15. We can break 15 apart into a smaller square root, which is 9, 3 times 3, and a larger square root, which is 16, which is 4 times 4. C is also a possible answer choice. The last answer choice, D, we can break apart the square root of 8. A smaller square root would be 4, 2 times 2. A larger square root would be 9, 3 times 3. And so D is not a correct answer. The square root of 8 would be between 2 and 3, not 3 and 4. meaning our answer choices are B and C. Now, to pick which one is better, if we're looking at the square root of 12, to go from 9 to 12, we have to go up 3. To go from 12 to 16, we have to go up 4. So 12 is going to be closer to the 3 value. Point A is closer to the 4 value on the number line, so we are not going to pick B. Looking at 15, to go from 9 to 15, we have to go up 6. To go from 15 to 16, we have to go up 1. 15 is closer to the 16, so therefore the square root of 15 is closer to 4. Number 5, which of the following would be the best estimate for the square root of 198? So when we take the square root of 198, which is not possible to be solved, we can break it down. Our smaller perfect square is the square root of 196, which is 14, 14 times 14. And the larger one would be the square root of 225, which is 15, 15 times 15. We know that our answer is going to be 14 point some decimal that we're unsure of. So we can go ahead and cross out answer choice D, 15.1. Now, we need to decide, is our decimal going to be a small decimal, closer to the 196, or is it going to be a larger decimal, closer to the 225? To go from 196 to 198, we're only going up 2, so it's very close. To go from 198 to 225, we're going up 27. So we want to pick an answer choice that is closer to the 196. So the closest answer would be a 14.1. Number 6, between which two integers would each of the following lie? So for the square root of 90, we break it down into our two perfect squares that it's close to. That would be the square root of 81, which is going to be 9 times 9, and the square root of 100, which is 10 times 10. So the square root of 90 is between 9 and 10. This problem does not actually ask us to find the decimal point. It just wants the whole numbers. For letter B, the square root of 175, we can break it down. We can break it down into the square root of 169, which is going to be 13 times 13. And we can break it down into 196, which is going to be 14 times 14. 175 is in the middle. So then our decimal is going to be between 13 and 14. And the last problem, we have the negative square root of 12. We break it down into the two closest perfect squares, which would be the square root of 9, 3 times 3, and the square root of 16, which is 4 times 4. So our answer choice is going to be between 3 and 4, but we do keep that negative sign, and so it's going to be a negative 3 and a negative 4. Number 7, Rebecca bought a square table for her kitchen. So here's our square table. It says the area of the table's surface is 65 feet. What is the approximate length of one side of the table? Now, when we were solving these problems last week, we would take the square root of the area and we would get our answer. However, we cannot take the square root of 65. We have to break it down into two perfect squares. The square root of 65 is closest to the square root of 64, which is going to be 8 times 8, and the square root of 81, which is 9 times 9. So we know our decimal point is going to be 8 point something, but we're not sure just yet of what that decimal will be. Now we want to know, is the decimal point going to be closer to the 8 or is it going to be closer to the 9? Looking at our perfect squares, to go from 64 to 65, we have to go up 1. To go from 65 to 81, we have to go up 16. So therefore, we're going to be closer to the 8. My guess, my approximation is going to be 8.1. I can write it off to the side and multiply it out to check my work. 1 times 1 is 1. 1 times 8 is 8. I put my placeholder 0. 8 times 1 is 8. 8 times 8 is 64. Add them up. 1 and 0 is 1. 8 and 8 is 16. 1 and 4 is 5. And then 6. 65.61 is close to my original 65. So 8.1 is going to be my approximate answer. Number 8, create and label a point on the number line below to represent an estimate of the following square roots. So for point A, we have the square root of 5. We're going to break down the square root of 5 into a smaller square root, 4, 2 times 2, and a larger square root, 9, 3 times 3. Our answer is going to be between the 2 and the 3 on the number line. But where is it going to go? Is it going to be closer to the 2 or is it going to be closer to the 3? To go from 4 to 5, we only have to go up 1. To go from 5 to 9, we only have to go up 4. So we're going to be closer to the 2. For point A, we're going to make a point close to the 2 and label it A. For point B, we're going to use the number, the square root of 88. We're going to break it down into a smaller perfect square, 81, which is 9 times 9, and 100, which is 10 times 10. To go from 81 to 88, we only have to go up 7. But to go from 88 to 100, we have to go up 12. So that means that our answer is going to be between the 9 and the 10, but it's going to be closer to the 9 than the 10. We can draw our point and we label it point B. For point C, we have the square root of 17. We break it down into our perfect squares. The square root of 16 is closest, which is 4 times 4. And the square root of 25 is highest, which is 5 times 5. So our answer is between 4 and 5. But which is it closer to? To go from 16 to 17, we're going up 1. To go from 17 to 25, we're going up 8. It's closer to the 4. So we're going to put our point closer to the 4 on the number line and label it point C. For point D, we have the square root of 118. We can break that down into our perfect squares, which would be the square root of 100, 10 times 10, and the square root of 121, which is 11, 11 times 11. Now, to find what it's closest to go from 100 to 118, we have to go up 18. To go from 18 to 21, we have to go up 3. So we're going to be closer to the 11 than we are the 10. And label it point D. The last problem, the square root of 56, we can go ahead and break that down into our perfect squares. The square root of 49, which is 7 times 7, and the square root of 64, which is 8 times 8. We want to see which one it's closest to. To go from 49 to 56, we have to go up 7. To go from 56 to 64, we have to go up 8. They are very close together. It is only slightly closer to the 49 than it is the 64. And so we can put this answer almost in the middle of 7 and 8 and label it E.